Welcome to Spaceverse, your portal to cosmic adventures. When astronomers look out into the cosmos, they aren't just gazing at the stars we see twinkling in the night sky. They're peering into the past. Light takes time to travel, and when we observe the most distant galaxies, we're seeing them as they were billions of years ago, during the infancy of the universe itself. Now, thanks to the James Webb Space Telescope, scientists have uncovered something extraordinary, something that could rewrite the way we understand the earliest days of galaxy formation. Hundreds of unexpectedly energetic objects have been spotted scattered throughout the distant universe, and they may be telling us that the cosmos was far more active in its youth than we've ever imagined. Using deep-field images from NASA's James Webb Space Telescope, researchers at the University of Missouri identified about 300 of these unusually bright objects. On the surface, they might look like galaxies, but astronomers aren't completely certain what they are just yet. What's clear, however, is that these objects shine far brighter than current models of early galaxy formation predict. And that's where the mystery begins. You see, galaxies forming so soon after the Big Bang should be faint. The physics of cosmic evolution tells us that galaxies at that time were limited by how quickly they could form stars. Gas was still cooling, matter was still condensing, and the first stellar populations were only starting to flicker into existence. According to our theories, these galaxies should have been dim, small, and slowly building themselves up. But what the Webb telescope is showing us is a different story entirely. These candidates are shining like cosmic beacons, so luminous, in fact, that they defy explanation under our current understanding. If even a few of these objects turn out to be what we think they are, Hao Jingyan, one of the study's co-authors, explained in a statement from the university, our discovery could challenge current ideas about how galaxies formed in the early universe, the period when the first stars and galaxies began to take shape. That's not a small claim. It's the kind of finding that forces astronomers to rethink the timeline of the universe itself. So how exactly did researchers discover these puzzling objects? The answer lies in a method called the dropout technique. This technique looks for objects that show up in redder wavelengths of light but completely disappear in the bluer, shorter wavelength images. Why would this happen? Because the farther away something is, the more its light stretches as it travels across the expanding universe. This stretching shifts the light into longer wavelengths. The visible becomes infrared. By identifying objects that vanish in the shorter wavelengths but still glow brightly in the redder ones, astronomers can pinpoint candidates that exist at extreme distances. And extreme distances mean extreme age. These objects aren't just far away in space, they're far away in time. The light reaching Webb from them has been traveling for more than 13 billion years, showing us the universe as it was not long after the Big Bang. To estimate just how distant these objects are, the team analyzed their brightness across multiple wavelengths. By doing this, they could infer each object's redshift, age, and even approximate mass. This is where the James Webb Space Telescope truly shines. With its near-infrared camera NIRCam and mid-infrared instrument MIRI, Webb is designed to detect the faintest light from the farthest reaches of the cosmos. These instruments can pick up radiation from galaxies that formed only a few 100 million years after the universe's birth, something no other telescope has been able to do before. As the light from these early galaxies travels through space, it stretches into longer wavelengths, shifting from visible light into infrared, Yan explained. This stretching, called redshift, helps us determine how far away these galaxies are. The higher the redshift, the closer the galaxy is to the beginning of the universe. And the redshifts of these new objects are incredibly high. That means we're peering almost all the way back to the dawn of cosmic time. But here's where the real puzzle lies. If these really are galaxies, they must have formed much faster than current models allow. Stars would have needed to ignite at an astonishing pace, gathering into clusters and galaxies with unprecedented speed. That kind of rapid formation doesn't line up with the way we thought the universe worked. So what's going on here? There are a few possibilities. These objects could indeed be galaxies, but ones that form through processes we don't yet fully understand. Or they could be something else entirely, exotic objects that mimic the appearance of galaxies but are powered by different mechanisms. Either way, their existence poses a challenge to the theories that have guided cosmology for decades. The next step is to figure out exactly what these objects are. To do that, the researchers plan to use targeted spectroscopic observations on the brightest of these sources. Spectroscopy is a powerful tool in astronomy. Instead of just measuring how bright an object is, spectroscopy breaks down its light into a spectrum, revealing the fingerprints of individual elements, the motion of gases, and a much more precise measurement of distance. Confirming the nature of these mysterious objects will tell us whether they're truly early galaxies or something else that's never been seen before. And if they do turn out to be galaxies, the implications are enormous. It would mean the universe built its first structures much more quickly than we ever imagined. That would reshape our understanding of cosmic evolution, forcing scientists to adjust or perhaps even abandon some of the models that describe how galaxies formed. It's important to remember that this is far from the first time the James Webb Space Telescope has surprised us. Since it began observing the cosmos in 2022, Webb has been rewriting the textbooks. It has spotted galaxies at record-breaking distances, revealed intricate details of star-forming regions, and even begun studying the atmospheres of planets orbiting distant stars. Its discoveries are not just adding details to what we know, they're challenging the very foundations of our understanding. This latest finding adds to that growing list. The idea that galaxies could shine this brightly, this early in the universe's history, suggests that the cosmos was far more dynamic in its youth than we ever expected. Maybe stars formed faster. Maybe black holes grew more quickly. Or maybe something entirely new was happening in those first few 100 million years after the Big Bang. Whatever the explanation turns out to be, these 300 mysterious objects are a reminder of just how much we still have to learn. The universe is vast, complex, and often unpredictable. Every time we build a new tool to look deeper, we find ourselves confronted with questions we didn't even know we should be asking. And that's what makes this moment so thrilling. We're standing at the edge of discovery, watching as our picture of the early universe shifts and evolves in real time. The next few years of JWST observations could completely change how we think about the origins of galaxies, the birth of stars, and the very nature of cosmic history. For now, these objects remain enigmas. But with Webb's powerful instruments and the persistence of astronomers worldwide, we're closer than ever to unraveling their secrets. And when we do, we may find that the story of the universe's beginning is even more dramatic and awe-inspiring than we ever dared to imagine. Out there, 13 billion years in the past, the universe may have been bursting with light far sooner than we thought. As Webb pulls back the curtain on these mysterious galaxies, one thing is certain: the story of our cosmic origins is only beginning to unfold. Stay curious and keep exploring with us here on Spaceverse.